In this video, we're going to be using the PhET Simulation Vector Edition to explore how we can describe the direction of various types of vectors using three different methods. So from the simulation, we'll choose Lab, and here we have a vector, and we want to figure out how can we specify the direction of this vector. Remember, a vector is something that has both magnitude and direction. So the first method that we'll look at is the polar positive and negative specification. Why we're using that is the specification that is used in this simulation. So for that way of describing vectors, we need to label the quadrants of the coordinate plane. So from math class, you may remember that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And what the polar positive negative specification says is that if the vector is in quadrants 1 or 2, it is measured counterclockwise from the positive x-axis. If the vector is in quadrants 3 or 4, it is measured clockwise from the positive x-axis, and it will have a negative value for the angle. So let's take a look at that using the simulation. So if I take this vector, and see if we can get it working here, we see I'm changing the direction of the vector, and now I'm into quadrant 2, and the angle is still being measured from the positive x-axis in the counterclockwise direction. However, if I come over into quadrant 3, we see that the angle shifts. It's now being measured clockwise from the positive x-axis, and the angle is now negative. So continuing that along, we see that again now in quadrant 4, the angle is still negative. It's being measured clockwise from that positive x-axis. The other way that we can specify a vector is by using the polar positive vector specification. And for that, we just say that the angle is always measured counterclockwise from the positive x-axis, regardless of what quadrant the vector's in. So if I again take this vector, this would be 49.4 degrees, it'd still be 128 degrees, and if I went into quadrant 3 and 4, this won't do it that easily because it switches on me, but for example, this right here, using the polar positive specification, this angle measured counterclockwise from the positive x-axis, this would be 270 degrees. So that is the polar positive specification. The other way that we can take a look at vectors is using the Navigator method. So using the Navigator method, what we do is we say, well, let's say if we have an angle like this, it's 42.3 degrees. What we have to remember is we have to remember our navigational directions. So we have north, east, south, and west. And if I take a look at the blue vector, I see that it is north of the east direction. So I would specify this vector as 42.3 degrees north of east. We usually put that in a little bracket. So it's 42.3 degrees north of east. Now I could also measure this a different way. If I take 90 and I subtract 42.3, that value, if we measure it in this direction, would be 47.7 degrees. So that direction would be east of the north direction. So it would be 47.7 degrees east of north. And I would put that in brackets. So play with that within the simulation here and try to get a feel for how to use the various types of vector specifications.